Welcome back to the today's class. Today we will be seeing about rectifiers. Rectifier is a electronic circuit which will convert alternating current into a direct current. So it will convert AC supply into DC supply. So there are about three types of rectifiers. The first type is half-wave rectifier. The second one is full-wave rectifier. And the third one is bridge rectifier. So the half-wave rectifier is being not used for many of the applications because its efficiency is low and it have some ripples in the voltage, or it will not properly rectify the complete AC signal into a DC signal. In case of full wave and bridge rectifiers are being used extensively in several applications. Now, first we will understand the basic concept how a half-wave rectifier is working. So, before seeing these concepts, we need to know some important points or characteristics of rectifier in which they are being measured. The first one is the regulation of output voltage. The output voltage is the end voltage given out by the rectifier after converting the AC signal into a DC signal. So the nature of the output voltage is DC in nature, which represents direct current in nature. As the load current changes, load voltage changes. Practically, load voltage should remain constant. So the output of the rectifier should remain constant irrespective of the change in the impedance of the load. Rectifier efficiency. It is how efficient the rectifier circuit converts AC power into DC power. So the efficiency represents how the conversion of AC signal is being converted into a DC signal. Peak value of current in a rectifier. It is the maximum value of AC in rectifier circuit. This describes the rating of the rectifier circuit. The total amount of AC, that is the peak value of the AC supply, which is being fed into the rectifier. So this is the maximum input, that's the AC supply peak input to the rectifier, and this decides the rating of the rectifier unit. Peak inverse voltage. Peak value of the reverse voltage across the diode decides the peak inverse rating, PIV rating of a diode. So you know the alternating waveform, that is the AC wave, have a positive amplitude as well as the negative amplitude. So the diode will conduct for the positive amplitude and it will blocks the reverse amplitude, that is the negative voltage. So the peak of the negative voltage which the diode can stop is known as the peak inverse voltage of the diode. Ripple factor. The output of a rectifier is pulsating DC. The amount of AC content in output is expressed by ripple factor. So while you are converting AC supply into a DC supply, the output which is given by the rectifier is pulsating in nature and it will have some ripples in the DC supply. So the output of the rectifier with some pulsating AC ripples in the DC supply is known as the ripple factor, and this is described by a mathematical or a quantitative amount which the AC content, how much AC content is present in the DC supply of the output voltage of the rectifier. Now let us see how a half-wave rectifier works. So this is the basic circuit diagram of a half-wave rectifier. Here you will be having a input AC supply with the magnitude of some voltage. Similarly, here you will be having a diode, and this is the load resistor which is being connected. So the AC supply, you know, the sine waveform will be in like this. Okay. Here, for understanding purpose, we are going to see the AC supply into two distinct quantities. Here, first in this figure, you are seeing the positive end of the cycle. You see this side only. Okay. Uh, Here you can see the positive edge of the AC supply is being repeatedly given into the diode. Here you can see once the positive supply is being fed, the diode is conducted, because now the diode is in forward biased, because the positive end is connected to the P junction and the negative end is connected to the load resistance, and the load resistance is connected back to the source. So the electrons starts to flow from the AC supply source into the forward biased diode, because you are applying positive terminal, positive voltage peak, that is the positive sign peak, into the diode. So it will conduct and it will enters into the resistance and it will return back to the source. Here you can see the maximum applied AC source voltage is 12 volt. So the applied source voltage is 12 volt, and the output across the resistance, you will be having a maximum of 11.39 volt across the resistor of 500 ohm, and the current is also shown. This yellow wave, you can see the current which is being flown. Next, in this figure, you can see this is the negative peak which is being applied to the halfway rectifier. Okay, here once the negative peak voltage is being applied, you can see after the source, here the negative supply, that is the negative peak, will be applied to the rectifier. Now the diode is in reversed state. So the diode will not allow the electrons to flow from this position to the resistance. So in forward states, you can see the diode is allowing the electron flowing from the P terminal of the diode to the N terminal of the diode, where in this case, in the reversed state, you can see the electrons are blocked by the diode. So the forward biased diode will allow the electrons, whereas the reverse biased diode will not allow the electrons. So once the positive end of the cycle is being present in the AC supply, you will have a positive supply in the resistor, whereas the negative supply present in the lower end will be blocked. You can see this is the negative end. There will be no negative end present here. Okay. And this is the complete setup, how the complete alternating cycle is being converted into a DC supply. You can see the positive end and as well as the negative ends are alternating in nature. Okay. Now you can see the while it is in positive terminal, you can see the electrons are flowing into the diode, whereas in reverse condition the electrons are blocked by the diode. So for the positive cycle of the sine wave, the forward biased diode will allow the current to flow into the resistance while it is in green position. Okay. When the supply goes back to the negative, it is indicated by the red color. Okay. When it is in red color, the electrons will be stopped because the diode is in reversed state. So the electrons will not flow into the resistance. So this is the basics of halfway rectifier. So the ripple factor R of the halfway rectifier is R is equal to RMS value of AC component of output divided by DC value of component of the output. So the AC component divided by the DC component. that is the RMS value of the AC component divided by the DC value of the output, gives the ripple factor. So the mathematical expression is square root of pi by 2 whole squared minus 1, which will be equivalent to 1.21. And the efficiency of the half-wave rectifier is the output by input. Here the output is DC and the input is AC. So output power divided by AC output power gives 4 divided by pi square. So the efficiency is 40.6 percentage. And next is the peak inverse voltage. So the peak inverse voltage is the maximum reverse voltage which is being applied to the diode. So in this case, PIV is VM, that is the maximum reverse voltage is VM, which is being applied to the diode. Transformer utilization factor, TUF. So this is the factor which is being used to find how much amount of transformer capacity is being utilized by the half-wave rectifier. So TUF is equal to DC power delivered to the load divided by AC power rating of the transformer. So 2 root 2 divided by pi square equal to 0.287. So it will approximately 28.7 percentage is the transformer utilization by a half wave rectifier. Next we will be seeing about the full wave rectifier, and this is the circuit diagram of a full wave rectifier. Here you can see the AC supply source of 50 Hertz, and this one is the transformer, and this transformer is a center taped transformer. Okay, after the center taped transformer, you can see this is the two diodes. Okay, there will be two diodes, and in the center tape transformer, under the center tap, you will be having the load resistance of 1 kilo ohm, or a load which is being connected with the two ends of the negative polarity of the diode. So the positive polarity of the diodes are connected to the transformer tappings, whereas the negative end is being connected with the resistances. Here you can see this is the source voltage sine wave which is being applied into the transformer, and here you can see this is the rectified output voltage which is you are getting as an output. Okay, in case of the positive terminal alone, you see the positive terminal alone is being given as a input into the sine of the transformer. Now you can see once the positive terminal, that is the positive edge of the sine wave is entering, you can see the upper portion of the transformer will be having current which is making the diode 1 in forward state. So the diode 1 which is present in here will be in forward state, and it will be conducting the electrons from the upper end of the transformer into the resistance through this position. Okay, so for the positive cycle you will be having this amount of current which is flowing in this direction as shown. Next we will be seeing for the negative cycle of the AC wave. When you are having the negative cycle of the AC wave, you can see the diode 1 is under reverse biased condition. Okay, for this the diode 2 is in reverse bias condition, whereas here you can see the diode 1 is in the reverse bias condition. Now the negative peak which you are applied here makes the transformer terminal at the bottom terminal will become the reverse peak. Okay, so what happens is this diode, that is the diode 2, will be in forward biased, and it will starts conducting the current in this direction. So in both the cases you can see the electrons entering into the resistor is in this position. So you can highlight that the electrons is entering in this position and leaving the resistor in this direction. So the current flow is unidirectional, it is not pulsating. Similarly, in this circuit, you can see for the negative end also, you see the electron starts to enter in this position and leaves the resistance in this position. So the electron starts to flow from the right hand side towards the left hand side of the resistor in both the positive as well as the negative peak. So what happens here when the complete circuit is combined together, the sine wave is applied in an alternating way. You can see uh, at the first time the current will be flowing through this one, and the second half cycle the current will be flowing in this one. So the positive peak, the diode D1 will be conducting, and for the negative peak the diode D2 will be conducting. So both electrons will be moving from the 1 kilo ohm resistance into the transformer. So what happens here is both the wave, that is the positive wave as well as the negative wave, is being transformed back to a DC supply, but the voltage which is present here in the output will be pulsating in nature. So it will not be a pure DC supply, you will be having a pulsating DC supply in a rectifier. Next, regarding the supply voltages, you can see the output of the source, that is the source voltage, is 12 volt, and here you can see the resistance voltage is about 11.302 volt, and the resistance load is about 1 kilo ohm. So let us move to the characteristics of full wave rectifier. So the ripple factor R of the rectifier is known as RMS value of AC component of output divided by DC value of component of output. So the mathematical derivation will be root 2 pi square divided by 8 minus 1 equal to 0.482, which is nothing but 48 percentage. Similarly, efficiency is equal to DC output power divided by AC output power. So here you can see 8 divided by pi square. In the previous case you have been seen 4 divided by pi square, because you are using a single diode. In here you will be having two diodes. So 8 divided by pi square will be giving an output efficiency of 81.2 percentage. Peak inverse voltage, and this is the maximum inverse voltage across the diodes. So here you will be having two diodes for rectification, so you will be having 2 into Vm, and the transformer utilization factor is TUF, the amount of transformer which is being utilized to use the transformer power to convert the AC into DC is known as the TUF. So TUF is a DC power delivered to the load divided by the AC power rating of the transformer, which is 0.693. Now let us move to the advantages of full wave rectifier. Here the transformer losses are less, because the complete wave, that is the sine wave as well as the negative peak, is being utilized. The losses in the transformer is less, whereas the efficiency of the conversion is higher. Large DC power output, so you can see the output power delivered by the rectifier to the DC unit is very large, and the ripple factor is less. The disadvantages of full wave rectifiers are the peak inverse rating of the diode is higher. So once the peak inverse rating is higher, you need to purchase a diode which is costlier. So you need to purchase a diode costlier in rating, as well as the amount spent on the diode is higher, because you need 2 into Vm. So the diode should be have a costlier rate. Next, the cost of center tap transformer is higher. So in this case, in a normal transformer, uh, you need to use the two windings, whereas in center type transformer you will be have 3 windings, so the cost of the center type transformer when compared with the 2 winding transformer is higher. The higher peak inverse voltage diodes are larger in size and costlier. So the physical view of the diode becomes bigger in case of higher ratings of PIV voltages. Now let us move to the last topic, one is the bridge rectifier. So this is the construction of the bridge rectifier. You can see this is the AC source of 40 Hz sine wave is being uh, provided to the bridge. Here this is the AC bridge rectifier circuit, and here you can see 4 diodes. Okay, this is the diode 1, diode 2, diode 3 and diode 4. There will be 4 diodes, and the one end of the bridge, that is the negative and the positive end of a diode, is being connected to the AC source, and the other negative and positive end of the diode is connected to the another end of the AC source. And similarly, here you can see the two N junctions of another diode is connected to the resistance, and similarly the two P junctions of the diode is connected to the other end of the resistance. So bridge rectifier will be having a very simple circuit. Here you can see this is the AC voltage which is being supplied by the source, and this is the output voltage of the rectifier. And here you can see this is the positive peak which is being fed into the diode. So first we will be seeing about the positive peak, then you will be seeing about the negative peak, then you will be seeing both these things combined in one shot. So this the positive peak, the electron starts flowing from the source into the diode. In this case, you can see the positive electrons, that is the positive biased voltage, is being present only in this diode, because when the positive electrons, that is the positive end, is coming here, that the electron is coming here, only this diode will be in forward biased condition. This diode is in reverse biased condition because the sine wave is positive peak. So what happens, the electrons starts to flow through this diode and enter the resistance. After the resistance, it again comes back through this position and present here. So in this time also you can see this diode is in reverse bias, this diode is also in reverse bias, so the current starts to flow through this D2 diode and return back to the supply. So in this case of the positive peak, the diode D1 and D2 will be conducting because of forward biased, whereas the diode D3 and D4 are in reversed biased condition. So D3 and D4 will not conduct, D1 and D2 will conduct during the forward biased supply or the forward biased nature. In the second stage, you will be seeing the negative voltage is being applied. When the negative voltage is applied, you can see the electrons starts to flow from this end into this. Okay. Now what happens is the diode D1 and D2, which are earlier conducting in nature, gets for reversed bias, but the diodes D3 and D4, which are in the earlier reverse bias state, act as in forward bias state. So the electron starts to flow from the diode D3, which is in forward bias, and enter into the resistance and return back into this position. And here in this state, this diode will be in forward biased, so it will go back to the source, electrons will go back to the source. So these are the two states. For the positive state, the electron will flow through the forward biased diodes D1 and D2. In the reversed bias states, the electrons will flow through D3 and D4. So in a bridge rectifier, you can say this D1 and D2 will be in forward biased, okay, when the positive sine wave is positive, okay, for this end of the sine wave. In this case you can see the diodes D3 and D4 are in forward biased, okay, when the sine wave approaches this end. So uh, the current direction, you need to check the current direction, okay. In the positive peak, what happens, the currents starts to flow through this resistor in this position, okay, when there is a positive end. Similarly, for the negative end of the sine wave, you have to see the current is in this position only. It is again going through this only. So the current direction represents the terminal ratings, that is, this is the positive terminal and this is the negative terminal, and this here also, this is the positive terminal and this is the negative terminal. So the terminals does not change, the positive polarities and the negative polarity did not change in their resistance. So this is the concept of bridge rectifier. Next, this is the complete sinusoidal waveform rectified by the bridge rectifier. Here you can see this is the source having a 40 Hz supply and which is being fed into the bridge rectifier, and this is the 100 ohm resistance of load. You will be having 4 diodes, okay. These 4 diodes are being used to convert the AC voltage into a DC voltage. Here on seeing the graph, you can see this is the supply voltage sinusoidal waveform. The green one is the voltage and the yellow one is the current. Next, on coming to this end, you can see the voltages that both the spikes, that is the negative as well as the positive as well as the negative, is being converted into a, DC wave. Both are being converted into a DC wave, but there is a factor that it is pulsating in nature. It is not in a constant way. To convert this pulsating DC supply into a AC supply, to convert this DC supply into a pure pulsating DC supply into a pure DC supply, you need to use a capacitor. So a capacitor, you need to use a electrolytic capacitor. Electrolytic capacitor should be used, and there are several ratings present in the electrolytic capacitors. These capacitors should be combined with the circuit over here, okay. You should combine the electrolytic capacitor with this. Once you do this, and the rating, assume the rating is of 1000 microfarad, and this is the positive terminal of the capacitor and this is the negative terminal of the capacitor. What happens is the graph of the output which you are seeing here will be converted into a straight wave due to the capacitance which is present here. This is the voltage and this is the time period. So this is the complete concept of rectifiers, okay. So in case of bridge rectifier, the ripple factor R is the RMS value of the AC component of output divided by the DC value component of output. Here pi divided by 8, here you will be having a 48 percentage of ripple factor, and the efficiency is again 81.2 percentage, and the peak inverse voltage is Vm. Because you are having 4 diodes, you may say that will be 4 Vm. It will be not like that, because the diodes are in parallel in nature. How they are parallel? When the positive cycle enters, you may see this one back. Okay, when the positive cycle enters here, the both the diodes, these two diodes are conducting. So these two diodes are parallel in nature. So what happens is the due to the parallel nature of the diodes, the two diodes will be conducting the same voltage. So you will be having a peak inverse voltage of Vm. Similarly, the transformer utilization factor TUF, DC power delivered to the load divided by AC power rating of the transformer will be 81.2%. So the advantages of bridge rectifier is AC voltage can be directly applied to the bridge. Transformer utilization is higher, applicable for large power circuits, can be used for higher voltage applications. So these are all the advantages of bridge rectifiers, and the disadvantages of bridge rectifiers is it is used for 4 diodes. So you need to purchase 4 diodes. This is the only disadvantage of bridge rectifier. And the application of bridge rectifier is used as a rectifier in power circuits to convert AC to DC. It is used in applications where floating output terminals are required. So on comparison, you can see this is the comparison. So for half wave, full wave and bridge, and here some particulars that are the number of diodes, efficiency, DC voltage, average DC current, ripple factor, peak inverse voltage, and transformer utilization factor. So you can go through these comparisons. The complete understanding, you need to see the graphics, what is happening in 3 diodes. So for that, I will play these videos for 1 minute of each one. Okay, I will show the videos of half wave, full wave and bridge for 1 minute. You can see these things in very clear manner so that you can understand. Next, you remember the points what I had said to you for the full wave rectifier. I will move to the full wave rectifier back. So you see this thing for the next 1 minute and understand what is happening in the full wave rectifier. is the bridge wave rectifier. Please remember the points what I had said to you, and try to understand how the bridge wave rectifier works by seeing this animation once again. Today we have seen the concepts of rectifier, and we have seen about the three types of rectifier: half wave, full wave and bridge rectifier. I hope you have understand all these concepts in a very good nature. Thank you.